have once again a massless pulling, and 15 kg block is here, 5 kg block is here. Initially they were at rest, and now this 5 kg block is given a speed of velocity of 10 meter per second in this direction. So what is going to happen is, because this side is heavier, so eventually this will come down. But for a time being, when the velocity of 10 meter per second has been given, so initially it will go like this. When it goes like this, it goes like this, and then finally it reverses direction and it will move like this. We are asked at what distance x the direction of motion is reversed. So this is the question. So let's do it. First, we can do it on the basis of laws of motion, and then we can do it on the basis of conservation of energy principle also, and then we can use work energy theorem, and we see whether all the three answers they match or not. So laws of motion, 50 kg is here, 5 kg is here. So this way the force is 150 Newton, and this way the force is mg 50 Newton. So net force is 150 Newton minus 50 Newton, that is force resultant is 150 minus 50 is equal to 100 Newton. Please see that is the net force is in this direction. Do not confuse the velocity with the acceleration. The net force is in this direction, the acceleration will be in this direction. That's why the retardation will be in this direction. When the acceleration is in this direction, so this block will be accelerating in this direction. That is, the velocity will be increasing in this direction. It means the velocity will be reducing in this direction, and that is what is happening. Over here the velocity is initially given at 10 meter per second, and when it comes over here, when it reverses the direction over here, the velocity comes out to be equal to 0. So that's why it is retarding this way. It is retarding this way, so accelerating this way. Net force is in this direction. So net force is 150 minus 50. Net force 50 Newton is equal to 100 Newton. So this 100 Newton is responsible for accelerating both the masses. Total mass 100 Newton is equal to 15 plus 5 total mass into acceleration. Acceleration comes out to be 5 meter per second square. So this acceleration will be in this direction. So this is in this direction. So it means when it comes from here to here, it will be retarding. We use v square minus u square is equal to 2as. Final velocity is 0 minus u square. What is the velocity over here which has been given? Initial velocity 10 square. 2 acceleration over here, that is when it is going from here to here, it is retarding. Retarding at minus 5 meter per second square. That is retarding at 5 meter per second square. But over here acceleration is asked. When retardation is 5 meter per second square, it means acceleration is minus 5 meter per second square. When acceleration is minus 3 meter per second square, it means retardation is 3 meter per second square. So 2 into a into s we have taken as x. So x comes out to be, that is 100 by 10 is equal to 10 meter. So we get x as 10 meter. Now let's use the principle of conservation of mechanical energy principle. We are using conservation of mechanical energy principle, so that we shall be talking about the losses and we shall be equating it to gains. That is what we have been doing. So we have two blocks. We take this as block number 1, we take it block number 2. So the terms which are associated with this is kinetic energy 1, potential energy 1, potential energy 2, and kinetic energy 2. For convenience only we return it. It goes from here to here. When it goes from here to here, let's talk about PE2. So when it has gone down, so obviously the potential energy has been lost. It has lost height, it has gone down. So potential energy has been lost by this block. So what is the loss? Please do not confuse potential energy and kinetic energy together. When the height of a body increases, it means its potential energy has increased. If height decreases, it means potential energy has decreased. If its velocity or speed increases, the kinetic energy has increased. If its speed reduces, the kinetic energy has reduced. It is only for a single block system we can say that is loss of potential energy. If there is a loss of potential energy, there is going to be a gain of kinetic energy. It is something like this. If there is a single block system, it has only two terms. One is potential energy, the other is kinetic energy. It is something like if there is only one person, like I am going, I have two pockets. One pocket here, one pocket here. I am carrying some money. So what I do is, initially I have some money over here, that is kinetic pocket. From there I after some time put it over here. So we say that loss of one pocket kinetic energy is equal to gain of potential energy. But students, what they do is, that is many a times they see what are the losses in potential energy and they put is equal to, that is this much is going to be gain of kinetic energy. No, no, no. If there are number of people instead of one block, for one block that is okay, because one block has only two terms. One is potential energy, the other is kinetic energy. If there is some loss in this, there is going to be some gain in this. But assume that is there are few people like me who are going together. They are blocks. They are multiple block system. If there is multiple block system, each block is having two pockets, potential energy, kinetic energy, and this money is interchanged between all the pockets. Someone is losing the money and someone is gaining the money. Some pocket is gaining the money. So we cannot say loss of potential energy is equal to gain of kinetic energy, or loss of kinetic energy is equal to gain of potential energy. We cannot say in multiple block system. We have to go from case to case. But one thing is sure, that whatsoever is the losses, they are going to be equal to gains, because the energy has not left the system or it has not been added to the system. So over here, P2, when it goes from here to here, H has been lost. So potential is lost. How much? 5 G, H is what? X. Potential work done. Now comes kinetic energy. Over here we say the velocity is 10 meter per second. When it comes over here, then the velocity is 0. Please see. So once again, the students at the back of mind, generally they say that is potential energy is lost, so that's why kinetic energy will be gained. So see what is happening over here. Potential energy is lost, even the kinetic energy is also lost. Over here it is 10 meter per second. When it comes over here, the velocity is 0. It comes to a stop. It rises, comes to a stop, because this side is heavier. Eventually this will come down. So from 10 meter per second, the speed has become equal to 0 meter per second. So there is loss of kinetic energy, that is half 5 into 10 square. This is also a loss. Let's come to this kinetic energy. When the velocity of 10 meter per second it has been given, this is like a train that is passing over a pulley. These are coaches. This is inextensible string. So whatsoever the velocity you give it to this, it is not that is you are given velocity to this. This is inextensible. So when you give velocity to this, there is some velocity. The velocity is also, the same velocity is given to this block also. So initially, when 10 meter per second velocity is given to this, it means the velocity of this block is also 10 meter per second initially. When it comes to stop, this also comes to stop. So when you talk with kinetic energy, there is a loss of kinetic energy. Obviously, initially it is 10 meter per second. Now it comes to a stop. When this comes to a stop, this also comes to a stop. So velocity is reduced from 10 meter per second to 0 meter per second. So loss for this, kinetic energy for this is half into, this is 15 into 10 square. This is the loss. Now comes to P1. This has gone from here to here. How much it has gone from here to here? It has gone the same distance. This has been lowered. This has been lowered by x meter. So this will go by x meter. So potential energy gain is, that is 15 gx. So what we are going to do is, now losses is equal to gains. We say 5 gx plus half 5e square plus half 15 into 10 square. So it is going to be half 20 into 10 square is equal to 15 gx. We can take this over here. So it is going to be 10. This is 20 by 10. 20 by 2 is going to 10. 10 into 10 square is going to 1000. So it is 15 gx minus 5 gx. So it is 10 gx. 10 into g is 10 into x. So x comes out to be 10 meter. Is same thing we get. Now let's do it on the basis of work energy theorem. So this is, once again I redraw, 15 kg over here, 5 kg here, and this has been given a velocity of 10 meter per second. It has been asked by what distance it will go before the direction is reversed. So when we intend to apply work energy theorem, the first thing is, let's see what is the net force and what is its work. Net force is 150 Newton here, 50 Newton here. So net force is acting is 100 Newton is acting this way. And when this goes x this way, so this goes x this way. Net force is acting in this direction and the displacement is in this direction. So obviously that is in the opposite direction, so angle is 180 degree. So what we say is work done by net force, that is we are interested in work done by net force. What is that work done by net force? That is F dot S only. What is that? That is 100 into x into cos 180 degree should be equal to kinetic final minus kinetic initial. And what is that? So this is 100 into x, cos 180 is obviously minus 1. So this comes over here. Kinetic final. Finally it has come to a stop. It is over here to here. When it has come over here, velocity comes out to be equal to 0. This velocity also comes out to be equal to 0. So the system is stationary at that moment. So kinetic final is 0 minus kinetic initial, that is half total mass. 20 into 10 meter per second was the initial velocity which was given. So this is like this, minus minus they get cancelled. So x is equal to, this is going to be 10 into this is going to be 100. 100 goes over here, 100. So x comes out to be 10 meter. We get once again the same answer by all the methods. So once we know so many methods by which we can get the answer, we don't have to look at the back of the answers or solutions. We know that is our answer is right.